In the 1990s, a team of researchers traveled to the Katawa island of Papua New Guinea to study the health of one of the last populations living almost entirely outside the modern food system. They examined over 1,200 people, teenagers, young adults, everyone who would typically be in peak acne years. The researchers found 0 cases of acne. Not low rates, not mild cases they might have missed. 0. They then looked at a hunter-gatherer group in Paraguay. 115 people observed for over 800 days. Same result. Compare that to the Western world, where studies estimate that between 79 and 95% of adolescents develop acne. And it doesn't stop at adolescence. Roughly 1 in 5 adults between 25 and 39 still deal with it. These populations weren't genetically different from people who get acne. Related groups, living westernized lives, develop it at the same rates as everyone else. So the variable isn't genetics, it's something environmental. Something about the way we live, what we eat, what happens inside our bodies. And yet, the primary answer to acne has been, for most of the last century, something we put on our faces. Benzoyl peroxide, salicylic acid, topical retinoids, antibiotics, prescription creams. These things work for some people, that's not in question, but for a significant portion, they don't, or they work temporarily, and nobody asks why. One survey found that 45% of acne patients abandon their treatment. The most common reason they gave? It just didn't work. Here's what almost never gets asked in a dermatology appointment. Why does the inflammation exist in the first place? Not what to put on top of it, but what is driving it from the inside. Because the research, and this goes back further than most people realize, suggests that for many people, the skin isn't where the problem starts. Inside your gut, you have a lining, a single layer of cells that acts as a controlled barrier between the contents of your digestive tract and the rest of your body. It has to make a constant decision: let nutrients and water through and keep everything else out: bacteria, bacterial fragments, toxins. That wall is held together by proteins called tight junctions. Think of them as the locks between the cells. When they're working properly, the barrier holds, but they can be disrupted by a diet high in sugar and refined carbohydrates, by chronic stress, by alcohol, by an imbalance in the gut microbiome, the trillions of bacteria living in your digestive tract. When those tight junctions weaken, the wall becomes more permeable than it should be, and something gets through that shouldn't. Inside gram-negative bacteria, the kind that live naturally in your gut, there's a molecule in the outer layer of their cell wall called lipopolysaccharide, LPS. In normal circumstances, it stays inside the gut. But when the barrier is compromised, LPS moves into the bloodstream. Your immune system, trained to treat LPS as a threat, responds immediately, activating a receptor called TLR4, triggering pro-inflammatory cytokines, pushing the body into a state of low-grade chronic inflammation. Not the intense inflammation of an infection, something quieter, persistent, systemic. And that systemic inflammation needs somewhere to show up. For many people, it shows up on the skin. The skin is one of the most inflammation-sensitive organs in the body. Highly vascular, exposed, with its own immune activity all responsive to the body's broader inflammatory state. This is why researchers increasingly describe acne not as a skin disease with occasional systemic effects, but as a systemic inflammatory condition that expresses itself through the skin. The face isn't the problem, it's the readout. Now, to be fair to dermatology, topical treatments and antibiotics work for many people, but there's a gap. Standard dermatology approaches the skin locally. What's on the surface? What's in the pore? Which bacteria are present? It rarely asks about the gut. For decades, the official position was that diet had no meaningful effect on acne. That position has shifted, but clinical habits move slowly. And there's a particular irony with oral antibiotics. They reduce the bacteria that contribute to skin inflammation, but they travel through the gut to get there, altering the microbiome, reducing bacterial diversity, potentially creating the very imbalance that research links to inflammatory conditions in the first place. Research published in Acta Dermatovenereologica compared the gut microbiomes of acne patients to people with clear skin. The acne group had measurably lower diversity, depleted in bacteria that produce short-chain fatty acids, compounds that regulate immune inflammation throughout the body, including the skin. Less diversity, fewer anti-inflammatory compounds, more systemic inflammation. There's one more connection worth understanding: the breakout that appears after a stressful week. The gut and brain are in constant communication through the gut-brain axis. Stress hormones, specifically corticotropin-releasing hormone, directly increase intestinal permeability. Research published in the journal Gut demonstrated this in humans. Psychological stress measurably opens the gut wall. Stress opens the gut wall, more LPS gets through, inflammation rises, and it surfaces on the skin. The stress-breakout connection isn't in your head. There's a documented physiological chain from the stressful event to the inflammatory response to the face. So, what's useful to take from this? The honest position is that gut-skin research is still developing. Most human evidence is associative, and anyone claiming a simple, proven gut fix for acne is ahead of what the data currently supports. But some things are worth knowing about. The strongest dietary signal in the research is glycemic load. Multiple randomized trials found that reducing refined sugar and processed carbohydrates measurably lowers acne lesion counts and reduces IGF-1, the hormone that drives sebum production. That's a free, low-risk place to start. A meta-analysis of over 78,000 people found a consistent association between dairy, particularly skim milk, and acne, with the mechanism appearing to be natural hormones in milk rather than fat or lactose. Fermented foods and dietary fiber feed the bacteria that appear depleted in acne-prone microbiomes. For anyone wanting to track this properly, Chronometer maps 84 nutrients across your diet and can surface deficiencies in zinc, omega-3s, and other nutrients connected to skin inflammation. And for those who want a deeper picture, some clinicians work with comprehensive DNA-based stool panels that detect things a standard test would miss: pathogens, parasites, fungal overgrowth, gut inflammation markers. They come with caveats around interpretation, and that's a conversation that deserves its own video. What the research keeps pointing toward is this: acne, in many cases, is the skin's way of reporting on something happening deeper. The gut-skin axis isn't a wellness trend. It's a biological communication system proposed by dermatologists in 1930, dismissed for 70 years, and now being revisited with increasingly compelling evidence. Topical treatments aren't wrong, but if they keep failing, it may be worth asking whether the problem is being approached at the right level. If this is something you've been dealing with, this video is worth saving. And if there's a specific angle you want to go deeper on, the diet side, specific nutrients, or how to actually test your gut, drop it in the comments. There's a lot more to cover.